Hello class, in this video I'm going to teach you about Pythagoras theorem. You have already learned Pythagoras theorem in class 8 and class 9. The proof of the theorem is not included in our syllabus, so I'll just give you a brief explanation of the theorem. The statement of the Pythagoras theorem says that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So as you can see in the figure here, I have a triangle ABC in which angle B is equal to 90 degree. So this is how we were taught in our previous classes. H square is equal to P square plus B square. Here H is the hypotenuse, P is the perpendicular and B is the base. But in class 10 we will have to use the sides instead of writing HPB. These things cannot be used, so AC square, the square of the hypotenuse, is equal to the sum of the squares of the other two sides. So the other two sides are AB and BC. The sum of the squares would be AB square plus BC square. So your theorem is AC square equals AB square plus BC square. What if I want to find the base of this triangle? So if you want to find the base of the triangle, there solving it from here will give you the same result, but you will have to make some adjustment. You have to take BC on this side, bring AC on that side, and so on. Transposing the terms will be needed. So you can do it directly. B square will be equal to H square minus B square. You should keep in mind that H is the longest side of the triangle. And so when you are finding B, you have to subtract P from H. So B square is H square minus P square. Similarly, P square is equal to H square minus B square. So with this, we will start our exercise. This is exercise 8.1. In exercise 8.1, we are given triangles and we have to see if they are right triangles or not. So we have already solved this in our Zoom class, and as I always say, this video is intended for those who have not or were not able to attend the Zoom class properly because of network issues. So moving to exercise 8.4, question number 1. Our question is, the sides of some triangles are given below. Determine which of them are right triangles. So as we have already said, here the given sides are 3, 4, 5. You have to take the two smaller sides, not the large, and we just assume that this is the larger side is the hypotenuse. So we will see if 3 square plus 4 square equals 5 square or not. If the square of these two, the sum of the square of these two is equal to the square of this one, then it's a right triangle, or else it is not. So the given sides are 3, 4 and 5. We will take 3 square plus 4 square, that is 9 plus 16, which is 25. Now this one will be squared separately. 5 square is equal to 25. So you can see 3 square plus 4 square is equal to 5 square, as 25 is equal to 25. So 3 square plus 4 square is 5 square. That means the triangle is a right triangle. So sub number 2 of question number 1 and sub number 3 of question number 1 will be assignment, and then we are to solve only numericals from this chapter. So we will jump to question number 8 of exercise 8.4. So this is question number 8 of exercise 8.4. Here the question says a ladder is placed against a wall such that its foot is at a length of 6 meters from the wall and its top reaches the window 8 meters above the ground. Find the length of the ladder. So we just have a simple diagram here. This is the wall, this is the ground, and this is the ladder. So the wall is 8 meters high and the length of the distance of the ladder from the ground, from the wall, is 6 meters. So how do we start? Let AC be the ladder and AB be the wall. So if this is a right triangle, as this is perpendicular, so in right triangle ABC we have AC square equals AB square plus BC square. This is from Pythagoras theorem. And then you just put the values as you did in class 9. AB square will be 8 square, this will be 6 square, that is 64 plus 36, 100. And now this square will be removed on the other side, so root 100 is 10. The length of the ladder is 10 meter. Easy, is not it? Then we shall move to our next question, question number 10. Here, two poles of height 6 meter and 11 meter are standing on the ground. One is 6 meter, one is 11 meter. Both of them are standing on the ground, and the distance between them is 12 meter. So if this distance is 12, the distance here, parallel distance here, is also 12. Let AB and CD be the poles. E is a point on AB. We have taken E, a point here on AB, such that EB and CD are equal. Suppose this is 6, this is also 6. Now, the whole tower is 11 meter, and this part is 6. The remaining part will be 11 minus 6, that is 5. So in triangle AEC, this is 5, this is 12. We have to find this one. This is the distance between the tops A and C. So we will just take this shaded region as the triangle. In triangle AEC, AC square is equal to AE square plus CE square. And then I had not finished solving this one because I had given this as their work. So we'll put the value AC square equals AE is 5, CE is 12. So AC would be equal to 25 plus 104, and then AC is equal to 169. So if I take the root of this, AC should be equal to root 169. AC is 13 meter. Therefore the distance of the top, the distance between their top is 13 meter. Easy, is not it? So our next question will be to solve question number 14. We'll move to question number 14. Now in question number 14, we have a 5 meter long ladder. The question says a 5 meter long ladder is placed leaning towards a wall such that it reaches the wall at a point 4 meter high. If the foot of the ladder is moved 1.6 meter towards the wall, then find the distance by which the top of the ladder will slide upwards on the wall. So here let AC be the ladder and AB be the wall. So this is a ladder, the initial position is AC, and this is the wall. Now let the foot of the ladder C move to D. So if this is moving this way, the ladder has to slide upwards to E. So the top of the ladder moves to E. Now you can see both of these, this line and the dotted line, that is the hypotenuses, are the ladders. So here AC and DE are 5 meter each. Now I'll be taking this triangle first. In right triangle ABC we have AC square equals AB square plus BC square. But as we have already said before, that to find BC using this formula is not that handy. So BC square will be equal to AC square minus AB square, hypotenuse square minus B square here. So I'll put the values 5 square and 4 square and then just calculate, and we will see BC is equal to 3 meter. Now that BC is 3 meter and this is 1.6, the remaining part has to be 3.0 minus 1.6, that is 1.4. So BD becomes, this part becomes 1.4 meter. Then After knowing this, we will take this triangle. We know the hypotenuse is 5, this is 1.4, we will be finding this side. So to find this side, our triangle will be EDB in triangle, EBD. EB, I'm to find this one, EB square will be equal to ED square minus BD square, this square. Let me repeat, EB square is ED square minus BD square. So we'll just put the values again, and you can see here the value of ED is 5, this is 1.4, 1.4 square is 1.96, if you subtract you'll get 23.04, the root of which is 4.8. So AE will be equal to, this is not visible properly, A is equal to 4.8 minus 4. I have to find this AE. So AE is 4.8, this total gap is 4.8, minus 4 will give you 0.8. So the ladder will slide upward by 0.8 meter. And then we have one more question, and our last question, question number 11. In question number 11, an aeroplane leaves an airport and flies due north at a speed of 100 km per hour. At the same time, another aeroplane flies and leaves the same airport and flies due west at the speed of 1200 km per hour. How far apart will the two planes be after 1.5 hours? That is what we are going to find. So I just made directions first indicated by arrow, and from here, from the point O, the first aeroplane flies this way towards A, the other one towards B. The speed and time are indicated here. So let the two aeroplanes fly from O, or you can write let the airport be O. Let the distance covered by the first aeroplane be AO, this one, AO, and the distance covered by the second aeroplane be BO. Then the time is 1.5 hour, that is 3/2 hour. Now we know the distance formula is speed into time. So AO will be, the speed is 1000 into time is 3/2. So we find 1500 km. That is the distance in kilometer. And for BO, we have to find this distance. Remember, this is the speed, not the distance. So we have to find the distance, and using the same formula, you find 1800 km. Now this is a triangle. We know the distance of these two. So one is 1500 km, the other one is 1800 km. We have to find the distance between these 2 points. So in right triangle AOB, AB square is equal to AO square plus BO square, and just put the values. So 1500 squared will be 225. As we have 2 zeros here, we'll double up to get 4 zeros, and here 18 square is 324, zeros will be doubled again. When we add, we can see a number here quite huge, and for factorizing this, we will just separate the zeros. We can separate here. 10,000 is taken away from 549. 549 when factorized will give 3 into 3 into 61. So instead of writing 3 into 3, I just wrote 9 into 61 into 10,000. Now the root of 9 is 3. The root of 10,000 is 100. Remember, 2 zeros become 1. These 2 zeros become 1. So you got 100 here. And this number will have no root. So 3 into 100 root 61. That is 300 root 61. Therefore, the aeroplanes will be 300 root 61 kilometer apart after 1.5 hour. So with this question, we have completed our exercise 8.4. Your assignment is to solve question number 1, sub number 2 and 3. If you have any query or any doubts, please feel free to contact me. Let this be all. Thank you.